Assalamu alaikum students. We are studying a course organic polymer and today our topic is glass transition temperature TG. When a plastic or rubber is cooled up to certain temperature, it becomes so hard and brittle that it breaks into pieces like glass on application of stress. What is glass transition temperature? Before going to move towards its proper definition, we have to understand these terms. Students, as when a plastic and rubber during the process of formation or production, when we move towards its cooling process, when the polymer is cooled up to a certain temperature, the polymer becomes so hard while cooling and it become a brittle. But when it break, when it throw, it will break into pieces, or when we apply any stress, that hard or brittle polymer is breaked into pieces. So now we will able to move towards its definition. Basically, the temperature below which the polymer become hard, brittle and glassy, and above which it is softer and flexible is known as glass transition temperature. Students, it is a point of temperature below which a polymer become hard, brittle and glassy, while above that point it becomes soft and flexible, and that point said to be the glass transition temperature point. Here is a temperature range below which at Tg it become a glassy, it become a hard, it become a brittle, and above this temperature it become a viscoelastic, mean flexible, and above this point its melting take place and this viscoelastic undergo to viscofluid. Here Tg represent the glass transition temperature, Tm is representing the melting temperature. So here are some polymers that have their certain temperature range at Tg and at Tm, melting point, melting temperature or glass transition temperature. Here is the polyethylene, which is having a minus 125 Tg degree Celsius, a glass transition temperature, and its melting temperature is 115. Polypropylene having minus 18 value of the Tg and 175 is its melting temperature. Polystyrene, the Tg value at Tg point is 100 degree Celsius, and polystyrene having its melting temperature is 240. Polyvinyl chloride or PVC, its Tg value is 80 degree Celsius, or its glass transition temperature is 80 degree Celsius and its melting temperature is 212 degree Celsius. Polyacrylonitrile having 97 degree Celsius its glass transition temperature and 241 is its melting temperature. So students, these are very important certain temperature points for each concerned polymer. Now students, what factors affecting on the Tg, glass transition temperature? There are various factors, we will discuss one by one each. First is the crystallinity, molecular weight, side group and chain, cross linking of the polymerization, plasticizer, coiled polymer chain, force of attraction between the chain. First is the crystallinity. If high the crystallinity of polymer, higher is its Tg value. If crystallinity is high, Tg value is high, what about then amorphous? Then amorphous polymer have low Tg. There are two forms, crystal form or crystalline form and amorphous form. If crystalline form having high Tg value, definitely amorphous form will be have low Tg value. Second is the molecular weight. Higher the molecular weight of the polymer chain or polymer, greater is its Tg of the polymer. However, Tg value depends upon molecular weight up to 20,000 for vinylic polymer. Important MCQs for the vinylic polymer, the range of polymeric weight is up to 20,000, and after that the Tg effect will be negligible. Next point is the side group and chains. If presence of the bulky side groups on the polymeric chain, it will increases the Tg value. The next point is the cross linking of polymer chain. The glass transition temperature of a polymer with higher extent of cross linking of the polymer chain, definitely its Tg value will be high. Next is the plasticizer. Addition of plasticizer to a polymer, it will decreases the glass transition temperature of the polymer. But why? Because the polymer become amorphous and there is increase in chain mobility. Students, if we add the plasticizer in polymeric chain, it will undergo to form amorphous in nature, and when the amorphous in nature polymer is formed, its Tg value is down, as we have already studied in the first point when we discussed the crystallinity, and we studied that the Tg value of the crystalline polymer is high while amorphous polymer is low. Next point is the coiled polymer chain. The polymer having coiled or spring like chain structure, it show the lower Tg value, for example rubber. The last point is the force of attraction between chains. The polymers having strong force of attraction, either intermolecular attractions, have greater glass transition temperature value, as the mobility of the chain is lesser in such cases. If force of attraction present between chain, students, the Tg value will be increases, but its mobility will decrease due to high force of attraction. So this was overall about today's lecture, glass transition temperature. I hope you understand this lecture. It's very easy, very straightforward things and important for the MCQs perspective. I hope you understand, you enjoy this lecture. Kindly share your feedback. Thank you.